This lesson is the first lesson of the 5th unit, and it will examine how to represent relations. So we are starting a new material, starting a new unit of work right now, and there is a lot of new terms and new material that we need to go through before we start looking at some of the problems. And the first thing we're going to do, as the title of this reference guide suggests, is we're going to look at how to represent relations, how to represent things in common. And at the top of the reference guide, as always, you'll see some definitions, and there's 4 here. Makes sense, there's a lot of new terminology given that we are starting a completely new unit of work. So the first definition is set. A set is a collection of distinct objects. And all that means is it's a group of any number of things that have something in common. So that is what a set is. It's a group of varying size, so it's not always a set amount of those things, but it's a group that has something in common. So for example, maybe we're talking about a set of the 31 NHL hockey teams. An element is an object that's in that set. So if we carry on with our hockey team example, like the Tampa Bay Lightning, that would be an element in that set of NHL teams. So the set is kind of a broad set, or a broad group of things that have something in common. It can be numbers, but it doesn't have to be. An element is one object from that set. Now we get into a relation, and that's what we're going to ultimately be representing today. So a relation is the association of elements found in one set with elements found in another set. So with this, we will be representing something in common between 2 sets. So we'll have 2 distinct groups of things, and there will be some way in which they are related to one another. That's what we'll be looking at today. And the final definition, again, it may be one you've heard of, probably in a graphing unit in a previous course, but that term is ordered pairs. Ordered pairs are 2 elements that are separated by a comma that are related to one another. So again, those could be numbers, but they don't have to be. And we'll see examples today of ordered pairs that are not numeric, that are just objects or things. Now there's 3 ways we're going to represent sets in this reference guide. The first is with what are called curly braces. And curly braces are just these things right here. So they're kind of like brackets, but not quite the same. And curly braces contain the elements within a set. If it's a set that goes on forever, or goes on for an infinite amount of time, you'll see at the end 3 periods. And this is called an ellipsis. And this denotes that a set just goes on forever. It carries on for forever. Okay? You'll see ordered pairs often represented inside of curly braces, and we'll get to examples of that a little bit later on. The second way in which we will organize relations is with a table. And everybody has used tables before, not even just in math class. You use them in any number of other courses. But a table is just an arrangement of data where elements on the same row are connected to one another, or they're related to one another, or they're associated with one another. The left-hand column should be organized. It should be either written alphabetically if we're dealing with words, or in increasing numerical order. So smallest number to biggest number if we're dealing with numbers. This won't always be the case, but it's going to help us later on in this unit. So when we're organizing data in tables, left-hand column is arranged alphabetically or in increasing numeric order. The right-hand column will just be the value that corresponds to the left-hand column. So we'll see what this looks like when we do some examples in a little bit. But the right-hand column may not be in alphabetical order, or may not be in increasing numerical order. It will be in any order, but it has to correspond to whatever value or word is in the left-hand column. It's also important to note that each column should have a heading, so that if anybody is looking at your table, they know more or less what you're trying to represent. The third representation is a little bit different. These are arrow diagrams, and you may not have seen these before. Arrow diagrams are ovals where each oval represents a different set. And you'll notice in the example below that the ovals are arranged side by side. So the ovals in the set to the left, they will represent information from one relation. The oval in the set to the right will represent information from another. And we're going to connect the data from each set by way of arrows, hence the name arrow diagrams. So all you're going to do, as the diagram below shows, is you're just going to draw an arrow from the element of the first set and what it's connected to in the element of the second set. And you can see with what I just traced that in this example, 1 is related to x. You'll notice in this diagram that the numbers and letters are arranged either in increasing numeric order or in alphabetical order. You don't have to do this, but it's a good idea and it's a good habit to get into just to keep everything organized in a particular way. So again, that's not mandatory, but you'll see when I do some examples that I tend to arrange my information in my arrow diagrams either alphabetically or in increasing numerical order, but again, this is not required. The last sentence is really important, and it's oftentimes this part of an arrow diagram that gets forgotten. And there has to be a linking sentence from the first set to the second set, so that if somebody is observing your arrow diagram, they more or less have an idea of what you're representing here. That linking sentence, again, it should link set A in this case to set B so that you can see how each element is related in set A to the element in set B. All right, so those are the 3 types of representations we're going to do, but as with anything in math, it's oftentimes more beneficial to see an example. So there are 2 on pages 2 and 3 of the reference guide, so let's take a look at those now. The first example, northern communities can be associated with the territories they are in. Consider the relation represented by this table. So on the left-hand side, we have the community. On the right-hand side, we have the territory. Obviously, these are Canadian territories. You can tell by the NWT for Northwest Territories, Nunavut, and Yukon. And in the left-hand column, those are places that are found within the various territories. And the first thing that you'll notice about this table, and this is really important, is that your left-hand column is alphabetical. So in this case, since we're dealing with words, it's arranged alphabetically. That is required for tables. Your left-hand column has to be alphabetical. The right-hand column doesn't. So the right-hand column, each element found in this set, so in, for example, the first Northwest Territories, that is related to the element from the other set that's on the same or in the same row. Okay, so it may not necessarily be in alphabetical order, and in this case it's not. We have Northwest Territories, then 2 Nunavuts, 2 Yukons, and then back to Northwest Territories. Okay? So the first thing that we're asked to do in part A is to describe this relation in words. And it's important, as a grade 10 student, that you use as many words as you can. You want to be thorough in any senior high course. So you shouldn't have an answer that's 3 or 4 words. You should have a couple of sentences here to explain what's going on. So if we're describing this relation in words, we would say something like, this relation shows various towns in northern Canada and the territory in which they can be found. And this is good. It depicts what's going on in the table, but you'll also want to include a second sentence. And that would be kind of what links your left-hand column to your right-hand column. So we would say something like, the columns can be linked by the phrase is found in. And all that last sentence is doing is it's saying that if we want to link the left-hand column to the right-hand column and have it read kind of like a sentence, we could use the linking phrase is found in. So if we take the top row, for example, we would say, Hay River is found in Northwest Territories. Iqaluit is found in Nunavut, and so on. So it's important to include that last line because it shows what that linking sentence will be. And we're going to use that again when we get to our arrow diagrams. But in words here, we've clearly described what's happening in the table. And it's important that when you are doing this, when you're describing relations in words, that you're thorough. You don't want to see just one or two words to describe something that is represented as a table with 6 or 7 rows. So now we're being asked to represent this as a set of ordered pairs. We mentioned ordered pairs a little bit earlier, but we haven't looked at an example yet, so that's what we'll do now. When representing something as ordered pairs, the first thing you're going to do is draw a curly brace. And that's going to open up your set. And now each part of the set will be depicted as ordered pairs. And when we do this, it's quite easy to do. You just take the element from your left-hand column and write that first, and then you separate it from the element in the corresponding right-hand column by a comma. So when we start, we would do something like Hay River, comma, Northwest Territories. And then we close our bracket. There's our first ordered pair. Now we separate ordered pairs with another comma. So you're going to be making a lot of commas here. You separate elements by way of a comma. You separate ordered pairs by way of a comma as well. And then you just go through your table. So Iqaluit is found in Nunavut. Close our bracket, another comma. You'll notice that the curly brace is still open. It will remain open until all of our ordered pairs have been written out. So now we move down to the third row, Nanisivik. That's also found in Nunavut. And now we're out of space, so we just go down to the next line, and that's fine to do. So we'll have to scroll a little bit here. So Old Crow, which is found in Yukon, is our next ordered pair. Close our bracket, and then we just finish it off with the capitals of each territory. So Whitehorse, which is in Yukon as well, and then Yellowknife, which is in Northwest Territories. It's a little bit messy, but that's okay. And there are ordered pairs, and you'll notice that everything is there. You'll notice that each element is related. Hay River is in Northwest Territories. Iqaluit is in Nunavut. You'll also notice that it begins and ends with a curly brace. So when you're representing or drawing your ordered pairs, you start with a curly brace. So now let's look at arrow diagrams. We talked about those before, and now we'll see how we make one. So you just start by listing everything that's in your left-hand column. So as I said before, I will continue to alphabetize this. I'll write it in alphabetical order. It's just a habit that I like to do. It's not mandatory, but you'll notice that I'll do it in each example that we do. So I'm just writing out everything that's in the left-hand column right now. Until I have all 6, which I now do. And since it's an arrow diagram, once that's done, we draw a big oval around it. There's our first set. That was the left-hand column of the table. And now, the second set. Well, with the second set, we only have 3 things. We just have the 3 territories. So you don't write duplicates. You don't write Nunavut twice or Northwest Territories twice or Yukon twice. So our second oval is smaller, and that's okay. What that means is we're going to have multiple arrows pointing to each of the elements in the second set. So we start with Hay River. That's in Northwest Territories. Well, the reason this is called an arrow diagram is you connect elements by way of an arrow. Iqaluit is in Nunavut, as is Nanisivik. Old Crow and Whitehorse are both in Yukon, and then Yellowknife is in Northwest Territories. So our arrow diagram looks like this, but I made emphasis about one part that I haven't filled in yet. You need a linking sentence. And the way you do your linking sentence is you just draw an arrow at the top, and you, as the name suggests, you write a sentence that links each set. So in this case, I'm just going to use is found in. So then if you were reading this arrow diagram, you would start with, let's say, we'll do a different one, we'll say Old Crow. You follow the arrow until you see that it points to Yukon, so you would read it as Old Crow is found in Yukon. And that's all there is with arrow diagrams. Now you may be asked to represent different data, sometimes from something like a bar graph, but you're still going to represent it the same way. So here, we have different breeds of dogs that are associated by their mean heights. Consider the relation represented by this graph. So now we have to take our data and represent it as ordered pairs, as a table, and ultimately as an arrow diagram. So we have quite a bit of work to do here, but luckily it's not too bad. So a set of ordered pairs means that we start by opening a curly brace. That's always where you start when doing ordered pairs. There's going to be a lot of writing here. So Afghan Hound is our first type of dog. And the mean height, well, that word mean just means average, if you remember. So it's somewhere between 70 and 80, and it looks to be kind of right in the middle. So I'm going to go 75. Now we move on to Chihuahua. Its mean height is 20. So 20 centimeters. Now we move on to Corgi. Corgis have a mean height of 30. And we just carry on with this. So Golden Retriever, but German Shepherd comes first alphabetically. And I think I'm just going to keep my alphabetical rule in place. So let me just take that H out of there. So German Shepherd, which has a mean height of 60. Same with Golden Retriever. Then we get to our final, which is a Malamute. Which is a mean height of about 65. It's between 60 and 70, kind of right in the middle. And then once we've written all our ordered pairs, we close our curly brace, and we move on to the next part. The next part is a table. So when we start a table, we need to start with a heading. We need to have this as something that if somebody looked at your table, you would, or they would, mostly be able to tell exactly what you're representing without any backstory. So if we represent our table as type of dog and mean height with centimeters and brackets, then it's pretty self-explanatory as to what we're talking about. So our first type of dog, once again, is an Afghan Hound. I'm going to just write out all my dogs first, and then I'll fill in all my heights. So sometimes these take a bit of time, as this one is, but that's just because you're writing a lot. So German Shepherd, Golden Retriever, And this is where the habit of alphabetizing even your ordered pairs and getting everything in the correct order, you can see it kind of pay off because now I just list my table in the same way that I've listed my ordered pairs. So 75, then 20, 30, 60, 60, and our final was 65. And since this is a table, just draw your border. And that's that. All right, so not much to that. Obviously, just make sure that your left-hand column is alphabetized, and that each of your element from your right-hand table corresponds to the correct element from your left-hand column. So the last thing that we're looking at is an arrow diagram. So arrow diagrams, for the third time and final time, we're going to just list our types of dogs as our left-hand column. So we have an Afghan hound. We have a Chihuahua, Corgi, German Shepherd. And now with this, a tendency may be to start abbreviating. Obviously, we are writing a lot, and sometimes people try to be lazy with this, and they'll write like GS or GR. But you don't want to do that. And the reason you don't want to do that is you have to kind of think of this as though somebody is just stumbling upon your arrow diagram or is just stumbling upon your table, and they maybe don't know exactly what you're talking about. So you want to organize it in such a way or be specific enough that anybody who finds any of these diagrams would know exactly what you mean by everything that you're writing. So it does mean you have to do a little bit more writing sometimes, but don't take any shortcuts. If it's a German Shepherd, write German Shepherd. Don't write something like GS. So now we just connect each element by way of arrows. And once that's done, we just need a linking sentence. And our linking sentence here will be a little bit longer than last time, so I'll give myself a bit longer of an arrow. And I would write something like, has a mean height of blank centimeters. Okay, so then if you were reading that, you would read it as something like, an Afghan hound has a mean height of 75 centimeters. A Chihuahua has a mean height of 20 centimeters. All right, and that's all that there is for this first reference guide. For right now, we're just looking at representing relations. We're going to go into much more detail with this over the course of the unit, but for now, just knowing those three types of representations is all you need to know.